Have you ever wondered how satellites maintain a constant position relative to the sun? They're not just floating aimlessly in the vast expanse of space. Rather, they're engaged in a complex celestial ballet, guided by the invisible hands of physics. This is where the concept of Sun-Synchronous Orbit, or SSO, comes into play. SSO is a specific type of orbit that allows satellites to pass over the same regions of Earth at roughly the same local time each day. This is crucial for the consistency of data they gather. It's like having a reliable eye in the sky that never blinks, always watching, always recording. The importance of SSO cannot be overstated. It's the backbone of our modern satellite systems, ensuring that we always have up-to-date information about our planet. Without the Sun-Synchronous Orbit, our ability to monitor weather patterns, climate change, and other critical aspects of Earth would be severely compromised. So, how does this Sun-Synchronous Orbit work? Well, it's a fascinating dance of physics and celestial mechanics, and it all begins with a satellite being launched into a nearly polar orbit. This means that the satellite travels from the north to the South Pole and back as the Earth rotates beneath it. By doing this, the satellite is able to pass over each section of the Earth's surface at the same local solar time each day. But the magic of the Sun-Synchronous Orbit doesn't stop there. There's another crucial factor at play which ensures that the satellite keeps up with the Earth's journey around the Sun. This is where the concept of precession comes in. In the context of an orbit, precession is the slow, gradual shift or rotation of the orbit's plane. Now you might be wondering, why is precession necessary? Well, as the Earth makes its annual journey around the Sun, the timing of the sunrises and sunsets changes. If the satellite's orbit didn't adjust or precess to compensate for this, the local solar time at which it passes over different areas of Earth would also change. But with precession, the satellite's orbit plane also rotates approximately 1 degree each day, which is just about the same speed at which the Earth orbits the Sun. So picture this. As the Earth moves along its path around the Sun, the satellite's orbit is also shifting, maintaining the same angle relative to the Sun. It's like the satellite is on a spinning top that's being tilted in sync with the Earth's orbit. This precise alignment means that the satellite passes over each section of the Earth at exactly the same local solar time every single day. This synchronized dance is what makes Sun-Synchronous Orbit so special. It ensures that the satellite maintains a consistent perspective of the Earth, regardless of the time of year. It's an elegant solution to a complex problem, a testament to human ingenuity. In this way, the satellite manages to keep pace with the Earth's rotation, providing a constant eye in the sky. But why is the Sun-Synchronous Orbit so vital for us here on Earth, you might wonder? Well, let's break it down. This unique orbit plays a pivotal role in various aspects of our lives, perhaps more than we realize. Firstly, weather forecasting. We all rely on accurate weather reports, right? Well, satellites in Sun-Synchronous Orbit provide us with real-time data, making weather prediction more precise than ever before. Then there's climate monitoring. These satellites give us a bird's-eye view of our planet, allowing us to monitor changes in temperature, vegetation, and ocean currents. This is crucial in our fight against climate change, but that's not all. In times of disaster, these satellites help in managing crises by providing invaluable images and data, aiding rescue efforts and minimizing damage. And let's not forget their military applications. From reconnaissance to communication, the Sun-Synchronous Orbit is instrumental in modern warfare. The Sun-Synchronous Orbit is a key player in our understanding and management of our planet. So, to sum it all up, we've delved into the mesmerizing world of Sun-Synchronous Orbit, a unique dance of satellites that ensures a constant illumination of our Earth. This intricate ballet in space performed by satellites is not just a spectacle but a necessity. The precise mechanics of Sun-Synchronous Orbit allow satellites to maintain a fixed angle with the Sun, providing consistent lighting conditions for observations. This is crucial for a variety of applications, from weather forecasting to environmental monitoring, and even military surveillance. The Sun-Synchronous Orbit is the unseen hero behind the scenes, making sure we have the data we need when we need it. In essence, it's a combination of science, mathematics, and technology, working in harmony to achieve a common goal. And that goal is to provide us with accurate, reliable information about our beautiful blue planet. Next time you check your weather app or marvel at a satellite image, remember the intricate dance of Sun-Synchronous Orbit that makes it all possible.